Preparing for Agentic AI Engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is an AI agent, and how does it differ from a conventional language model application? A language model application usually maps an input to an output through a mostly predefined flow. An agent adds a goal-driven control loop. It observes context, reasons about the next step, calls tools, evaluates results, and continues until a stopping condition. For example, a support agent can search policies, inspect an order, and issue a refund. I would constrain autonomy with permissions, budgets, timeouts, and human escalation rather than treating unrestricted action as intelligence. While answering, define agents through goals, perception, reasoning, action, and feedback. Contrast fixed pipelines with dynamic decision-making, tool use, state, autonomy, environment interaction, and the importance of bounded execution. Question 2. How would you design a reliable agentic workflow for a multi-step business process? I start by separating deterministic steps from decisions that genuinely require model judgment. Each step receives typed state, invokes a narrowly scoped tool, validates its output, and records an idempotent key. The orchestrator persists checkpoints so a timeout can resume safely instead of repeating side effects. I add retries only for transient failures, route ambiguous cases to approval, and expose traces for debugging. This design preserves flexibility while keeping critical business behavior predictable. Make sure to cover workflow decomposition, state transitions, tool contracts, retries, idempotency, validation, checkpoints, observability, failure recovery, human approval, and the decision between deterministic orchestration and model-driven planning. Question 3. When would you use a workflow, a single agent, or a multi-agent architecture? I choose a workflow when the sequence is known and correctness matters most, such as invoice approval. I use a single agent when one reasoning loop can select tools without excessive coordination. Multi-agent systems make sense when roles are genuinely distinct, for example research, verification, and synthesis, and parallelism improves outcomes. They also multiply latency, token cost, and debugging difficulty, so I would first prove that specialization or independence delivers measurable value over a simpler design. In your answer, compare predictability, complexity, coordination overhead, specialization, latency, cost, and failure modes. Explain why multi-agent designs need clear roles, shared state boundaries, and measurable justification. Question 4. How should an agent decide which tool to call? Tool selection should combine model reasoning with explicit constraints. I expose concise descriptions, typed parameters, examples, preconditions, and expected errors, then let the model propose a call. A policy layer checks authorization, argument validity, cost, and whether the tool is necessary. After execution, the agent validates the result and can ask for clarification or choose a fallback. I avoid exposing dozens of overlapping tools because ambiguity increases incorrect calls and token usage. Be sure to mention tool descriptions, schemas, preconditions, relevance, confidence, planning, tool selection errors, validation, fallback behavior, and policies that prevent unsafe or unnecessary calls. Question 5. How do you prevent hallucinations in an autonomous agent? I reduce hallucinations by grounding claims in retrieved or tool-generated evidence rather than relying on model memory. The agent should cite source identifiers, use structured schemas, and refuse or escalate when evidence is missing. For high-impact answers, I add independent verification, consistency checks, or a second retrieval pass. I also evaluate factuality on representative tasks. No technique eliminates hallucination, so the system must make uncertainty visible and limit actions when confidence is low. Focus on grounding, retrieval, source attribution, structured outputs, tool verification, uncertainty handling, constrained generation, cross-checking, and evaluation. Distinguish reducing hallucinations from eliminating them entirely. Question 6. How would you implement memory for an agent? I separate working memory from durable memory. Working memory contains the current task, recent messages, tool results, and plan. Long-term memory stores selectively approved facts or past episodes in a searchable database with timestamps, provenance, and access controls. Retrieval should be relevance and recency aware, then injected through a bounded context budget. I would summarize old interactions, allow correction and deletion, and never persist sensitive information merely because the model mentioned it. Cover short-term conversation state, long-term memory, episodic versus semantic information, retrieval, summarization, relevance, freshness, privacy, deletion, conflict resolution, and avoiding unbounded context growth. Question 7. How do you manage context windows and token costs in long-running agents? I treat context as a budget, not an unlimited transcript. The agent keeps a compact task state, summarizes completed work, retrieves only relevant historical facts, and truncates verbose tool responses to essential fields. I preserve constraints, decisions, identifiers, and unresolved issues explicitly so compression does not erase requirements. Prompt caching and smaller models can reduce cost, while a larger model handles difficult steps. I monitor token growth because latency and quality often degrade together. Discuss context budgeting, summarization, retrieval, state compression, selective tool outputs, prompt caching, model routing, truncation policies, and preserving critical facts without silently losing task requirements. Question 8. What techniques make agent tool calls safe and idempotent? I classify tools by risk and make read-only operations broadly available while requiring approval for irreversible changes. Every write accepts an idempotency key, validates inputs, and records an audit event before execution. Retries are safe because duplicate requests return the original result rather than creating another side effect. For complex operations, I use transactions or compensating actions and offer dry run previews. Tool permissions should be scoped to the user, resource, and current task. Mention least privilege, typed inputs, confirmation gates, idempotency keys, transactional boundaries, dry runs, audit logs, retries, compensating actions, and separating read-only from state-changing operations. Question 9. How would you defend an agent against prompt injection? I assume retrieved documents, web pages, emails, and tool outputs are untrusted data, not instructions. I label those boundaries clearly, keep system policy separate, and prevent content from directly changing permissions or tool definitions. A policy gateway validates proposed actions, while tools expose minimal capabilities and redact secrets. I test direct and indirect injection cases continuously. Because models can be persuaded, defense in depth matters more than asking the model to ignore malicious text. In your answer, cover untrusted content boundaries, instruction hierarchy, content labeling, tool isolation, least privilege, output validation, retrieval threats, indirect injection, monitoring, and why model-only defenses are insufficient. Question 10. How do you evaluate an agent when its behavior is non-deterministic? I evaluate more than the final response. For each task, I define success, allowed actions, unacceptable actions, latency, cost, and evidence requirements, then run multiple trials because outcomes vary. Trace-based evaluators inspect tool choice, arguments, ordering, and recovery behavior. I combine automated checks with human review for nuanced quality and maintain adversarial regression suites. Reporting confidence intervals and failure categories prevents one impressive demo from hiding unreliable trajectories. Be sure to discuss task-based benchmarks, traces, success criteria, trajectory evaluation, human review, reproducibility, adversarial cases, statistical confidence, regression sets, and separating final answer quality from action safety. Question 11. What observability would you build for a production agent? I instrument every run with a correlation ID, task state, model and prompt version, tool calls, latency, token counts, retries, and termination reason. Traces should show the trajectory without exposing secrets, so sensitive fields are redacted and retention is controlled. Dashboards track success rate, escalation rate, cost, latency, and tool failure frequency. I also capture user outcomes and feedback, because a technically complete run can still fail the business objective. Cover structured traces, prompts and responses with redaction, tool latency, token usage, state transitions, errors, model versions, correlation IDs, user outcomes, alerts, and privacy-aware retention. Question 12. How would you reduce latency and cost in an agentic system? I first profile the trajectory to find whether latency comes from model calls, tools, retrieval, or serialization. Independent tools can run in parallel, while prompt caching and compact schemas reduce repeated tokens. I route simple classification or extraction to smaller models and reserve stronger models for planning or ambiguity. Caching stable results and stopping once acceptance criteria are met helps further. Every optimization must be checked against task success, since cheaper incorrect actions are not savings. Discuss model routing, parallel tool calls, prompt caching, retrieval optimization, fewer planning steps, streaming, batching, response limits, caching, early stopping, and measuring quality before optimizing aggressively. Question 13. How do you choose between prompting, fine-tuning, and retrieval augmentation for an agent? I use prompting for behavior changes, formatting, and lightweight policy guidance. Retrieval augmentation fits changing or private knowledge because documents can be updated without retraining and can provide citations. Fine-tuning is appropriate when the model repeatedly needs a stable style, specialized tool calling behavior, or efficient adaptation at scale, assuming quality data exists. I usually establish a retrieval and prompt baseline first, then fine-tune only after evaluation shows a persistent, measurable gap. Explain when each approach fits, including behavior, domain knowledge, freshness, data requirements, maintenance, cost, evaluation, and privacy. Mention that these methods can be combined rather than treated as exclusive. Question 14. How would you design planning and execution for an agent handling complex tasks? For complex tasks, I represent the plan as typed steps with dependencies, inputs, expected outputs, and completion criteria. The executor runs ready steps, validates results, and updates durable state. If evidence invalidates an assumption, the planner revises only the affected portion instead of restarting everything. I impose limits on depth, time, and tool calls, and require verification before declaring success. Upfront planning improves visibility, while iterative replanning handles uncertain environments. Mention goal decomposition, explicit plans, replanning, execution state, dependencies, verification, budget limits, partial failure, stopping criteria, and the trade-off between upfront planning and iterative reasoning. Question 15. How should an agent handle errors, retries, and partial failures? I classify errors before deciding what to do. Network timeouts may merit bounded exponential backoff with jitter, while invalid arguments require correction rather than repetition. Each attempt persists state and carries an idempotent key to prevent duplicate side effects. If a workflow partially succeeds, the agent should resume from the last checkpoint or execute compensating actions. After a retry budget is exhausted, it presents the failure clearly and escalates instead of improvising. In your answer, distinguish transient and permanent errors, use exponential backoff, classify failures, preserve state, support compensation, avoid retry storms, and escalate when recovery confidence is insufficient. Question 16. What role does human-in-the-loop approval play in agentic systems? Human approval belongs at points where impact, uncertainty, or irreversibility exceeds the system's risk budget. The agent should show the proposed action, evidence, affected resources, and consequences, not merely request a generic confirmation. Low-risk reversible tasks can remain autonomous, while payments, deletions, or sensitive communications require review. I measure approval overrides and false escalations to tune thresholds. Good human-in-the-loop design improves accountability without turning every workflow into manual work. Cover risk-based escalation, approval thresholds, clear previews, useful context, reversible actions, auditability, avoiding approval fatigue, and designing humans as informed decision-makers rather than passive button clickers. Question 17. How would you secure an agent that can access enterprise systems? I propagate the authenticated user's identity and enforce authorization at the tool or service boundary, never trusting the model's claim about permissions. Credentials live in a secret manager, and short-lived scoped tokens limit blast radius. I isolate tenants, sandbox code execution, restrict network access, and apply data loss prevention to inputs and outputs. Every sensitive action is audited and revocable. The agent receives only the minimum data and capability required for its current task. Be sure to mention identity propagation, least privilege, tenant isolation, secret management, authorization checks, sandboxing, data loss prevention, audit trails, network controls, and revocation. Question 18. How would you implement code execution safely for an AI agent? Generated code is untrusted, even when it appears harmless. I execute it in an isolated sandbox with a restricted file system, disabled or allolisted network, ephemeral credentials, CPU and memory quotas, process limits, and strict timeouts. Dependencies come from controlled images rather than arbitrary installation. Outputs are size-limited and sanitized before returning to the model. I log execution metadata and terminate runaway processes. For sensitive workloads, I prefer deterministic service APIs over general code execution. Discuss isolation, sandboxing, resource quotas, file system and network restrictions, dependency control, timeouts, process limits, result sanitization, malware risks, and why generated code must be treated as hostile. Question 19. How would you architect a scalable, multi-tenant agent platform? I would separate an API layer, durable workflow coordinator, task queue, stateless agent workers, tool gateway, and persistent state stores. Queues absorb bursts, while per-tenant quotas and concurrency limits prevent noisy neighbors. A model gateway centralizes routing, fallback, rate limiting, and cost accounting. State and logs require tenant-aware access controls, and workers should be horizontally scalable. Regional placement, backpressure, and graceful degradation keep the platform reliable during provider or traffic failures. Focus on stateless workers, durable orchestration, queues, tenant isolation, quotas, concurrency controls, model gateways, shared observability, regional deployment, backpressure, and noisy neighbor protection. Question 20. Describe an agentic AI project you would build, and how you would measure its business impact. I would build a support resolution agent that retrieves policy, investigates account data, drafts a response, and requests approval for refunds. I would begin with a narrow issue category and compare it against current resolution time, escalation rate, customer satisfaction, and error rate. Success requires equal or better quality, lower handling time, and controlled cost, not just fluent answers. I would monitor unsafe actions, abandonment, and override rates, then expand only after staged production evaluation. In your answer, connect user pain to agent capabilities, define a narrow initial scope, explain architecture and safeguards, establish baseline metrics, and quantify quality, productivity, cost, adoption, and risk outcomes. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.